Smile on the
Huh? You got a smile?
Yeah.
That's better than an A. Okay. So, yeah, a little bit. Okay, so last time we had a look at sequence. Like A1, A2, A3, etc. Yep. Today we're going to have a look at something called a series, which is nearly the same thing, except you do this. Okay, so can you write those two words down? Make sure you're clear about the difference. Yeah, got that? Yeah. Cold?
No.
Oh no, you're sick? Because of Amanda. She was sick yesterday.
No.
She made you sick.
Spicy. Too spicy. Chinese Chinese food.
Too spicy?
Very, very spicy.
It's only 11 o'clock. Why did you do that?
My mouth and my stomach is not the same level.
Your mouth likes spicy food, but your stomach does not like spicy food. I understand, yes. Okay. So the symbol we use for when we want to add, is this symbol, which is called sigma. Sigma, okay? So I'm sure some people have seen this before, but if I write something like this, from the first to the fourth term, add them together. So for example, if I write this, okay, 30 is it? 16 and 9 is 25 and 5, 30 I think, for example. It is actually. First lesson is easy. Okay. So what about if I wrote something like this, for example? Well, what would be the first number here? 1 over 3. Plus 1 over 4, 1 over 5, 1 over 6. Okay, let me give you one to try by yourself. Try this for me. Calculate this. It will be 0 factorial plus 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial, which would be 1 plus 1 plus 2 plus 6 plus 24, which is 34. You said 10?
Yep. Before.
Ah. Start at 0, go to 4. You got the idea? Yeah, okay.
How much is 34?
Yeah. Is it not? I think so.
Factorial is 1.
Yeah.
Yeah. Oh, yeah.
Now, your calculator, I lost my calculator, but your calculator, not that one, and not that one.
I ordered that one. Nobody has that.
Let's see this one.
No. No.
No, not this one. Not this one. Oh my goodness, does anybody have the calculator I sent to buy? Yeah, you do it. And that's it, is it? Yeah, give it to me for a second, Joe.
Maybe. It does have something.
No, I just care about my calculator I asked you to buy right now. Okay. I want to show you something here. Okay. Watch this. Whoops. Okay. Can you see that? Is that a yes? Here? There? Hang on. I know the problem is there's stuff on my page. Alright, let's try this again.
Yeah.
There. You see that?
Yeah.
So you can type these in on your calculator, and the only thing is on your calculator you use the letter X instead of N. Do you see that? Oh, can you see the answer? There, 34. Same answer. So this is one of the reasons I asked you to buy this calculator, because it can do things like this.
I'm looking on this.
No, you need to buy the one I asked you to buy. It's only that. Buy it on Amazon then.
Oh.
You have the internet, don't you? You've heard of the internet, yeah? You can buy it online.
Yeah, I have it. I'll be careful.
Argos is also a great place for things like this. Thank you, Jen. So, this is useful in the exam because it means you can check your answer. Huh? The book is on the top right if you look. You press shift and there it is there. So then you just move the arrows around and put in the numbers. So, you know, this is why I asked you to buy this calculator, because it's the most useful for this class. What's wrong?
She just, it's painful.
You're sick.
Where you can
I think you can buy this calculator on internet, Amazon maybe. Hang on, let me have a look here for you. Children. Hang on.
Did you pause the video?
The video's recorded. No, don't be that. Casio 991.
No, it's 95.
No, this is it right here. Look, there it is right there.
So expensive. Yeah.
How much?
Expensive. But hang on.
4 pounds. 14 pounds.
Sorry,
See if we can get it cheaper on eBay.
No cheaper.
Hang on.
It's cheaper.
Hang on. It is. No, that's just the batteries.
More expensive.
$19.
Wow.
No, it's only 16 or 15.
No, that's 16 euros. Now hang on. How much is a hot chocolate in Starbucks?
€3. Okay, for this small.
No, they buy large. Venti hot chocolate.
Three.
Chocolate and 4.
Senpai hot chocolate, how much?
Oh, 310.
At least 310. I would have thought 410. If we say 350, that's 5 hot chocolates.
500.
Yeah.
500.
Yeah.
Is that
About this one, I think,
It's
5 chocolates or calculator?
So it's like China. You can calculate the difference between the China and yuan
Oh.
and the euro.
Right, hang on.
You just type RMB.
What is it? IMB?
Yeah, RMB.
Like-
RMB.
RMB.
The
M.
The big.
Cheap.
Cheap.
Cheap. So cheap. So cheap.
No. That's 420 RMB is so expensive.
Is it? Okay.
Yeah, don't
Well, think about this. Which would you rather have? A phone or a calculator?
A phone.
A calculator, that's right. Well, hang on. Let me rephrase it. Which is more important for your exam? Which can you use in the exam?
Last answer.
That's supposed to. Alright. So, oh yeah, and the other website here, Argos. Everybody knows Argos in Ireland.
Okay, fine.
You know Argos, don't you?
Yeah.
CEO.
I'm from France.
It's fine. Calculator.
Oh, here it is.
The watch.
No, this is calculator. Just for calculator. Search calculator.
Where's calculators?
Search calculator.
Oh, calculator.
There you go.
No, don't buy it there. It's nearly double. Okay, now that's expensive, I agree. $29.99 is expensive.
This one is, I bought it for 17.
Where? Oh, yeah, but I don't like that one.
It's still 35.
Yeah, but whatever. Look, I'm just saying, if you buy the Casio 991, you can have more features on it. That's fine. What the calculator you have is fine. I'm just saying the other one is better.
Yeah.
But you can use that one. Okay? Let me give you another one to do. Try this one for me. Sorry. Actually, let me just change this. One over. Do you know what to do? 1 over n factorial. Try this one for me, please. Give it to me as a decimal.
2.7?
Yes. Yeah. Now what about this? Indeed. So in the exam, they'll only give you small numbers to do. Okay? But what about this one? 400.
If you have that tool, then you can do it.
Yeah, well, this is the thing, if you have the calculator, you can do it on the calculator. But don't worry, in the exam they'll keep the number small, less than 10, okay? But in fact, I actually know what the answer is here.
What?
2.7
Oh.
I won't tell you. So the point, when you just did that for me a minute ago, with the 4, up to 4, what answer did you get? 2.708.
Yeah.
And when I go to 1,000, I say I can get 2.718. So in fact, this series doesn't diverge, it, what's the word? We had it yesterday? Opposite of diverge? Converge. So this one here actually converges. It doesn't keep getting bigger. What about this one, n squared? What do you think? Converges or diverges? Diverges.
Yeah.
This one here, n squared. Divergent.
Wow.
Well, here's a... You mixed up the meaning? Yeah. So it is divergent, agreed? Yeah. So it keeps getting bigger. So for example, if I go up to 40, will this number be bigger, smaller, or nearly the same? Much bigger. So it converges. Now here's an interesting one. What about this one? If I go up to say 60. Yeah, you can converge it because you're looking at this and it's getting smaller. Yeah?
But it's in.
In fact, believe it or not, this one here is divergent.
Right.
The proof is something you do at university. But I'm just saying, my point I'm making is, it's not always clear from just looking at it if it will converge or diverge. So, the first example, we are all happy to say that diverges, okay? And the last example, we're happy to say converges because look, after I go to 1,000, I get, this is the answer. But the middle one is not so clear. It looks like we think it should converge because it's getting smaller. In fact, it diverges. This answer keeps getting bigger.
No, you said if the sequence stays the same after some, it's convergent.
Yeah.
Now same, then divergent.
Yeah.
It's changing, it's divergent.
I didn't say it stays the same. I said if it's trying to reach a number, if it looks like it's trying to stay the same. I know it will never stay the same because it'll keep changing by a little bit. Yeah. Yes. Oh, you have it on your calculator. Good. All right. 2 people can do it. Okay. Let me just give you one more interesting example.
So if it's decreasing, it's convergent.
Not necessarily, because it could decrease to minus infinity. What you want to know, it's convergent. You think it's convergent if the numbers start to change very slowly. So like if it goes like this, 1.5, 1.6, 1.61, 1.612, 1.613. This, I think, is convergent to some number like 1.6.
But this one is, stays the same.
Now, it stays the same only because the calculator can only go to 10 decimal places. It's actually changing. It's just we can't see it because the number of decimal places. That's all. One more. Give me this. Zero to 4, 1 over n squared.
30?
Huh?
30?
1 over n squared.
Arrow.
1 over 3.
No.
What, 3-1?
Oh, sorry. Bad teacher. Bad teacher. Start at 1, of course. Can't start at 0.
That's it. One over 55. 1.4.
That sounds about right.
1.8. 0. 0.01.
What did you get?
0.01.
No, that's too small. You said 1.4, was it? Yeah. 1.423, etc. Yeah. What do you think? Is this convergent or divergent? What do you think?
It's convergent.
We think it's convergent, yeah. Okay, try to do this last one for me. I'll wait. Take your time. Just go to infinity, please. I have plenty of time. Start at 1. Keep going. Tell me when you get to infinity. Yes. Now you can't do this one, of course, because you only have so much time. Yes. But in fact, I actually know the answer here. I know that if I continue to do this forever, this will become equal to pi squared over 6. Can you type this in, Fahad and KJ? What do you use pi squared over 6?
It's 1.64.
Yeah. So look, think about it like this. Look up, please. Look. After I go from 1 to 4, I get 1.423. If I continue to add, after I get to infinity, I haven't made much progress. I've only gotten to 1.64. So this sequence is convergent, but this one converges very quickly.
Like this is a fact that it will be equal to pi.
It is actually, yeah. The proof you will see next year, maybe. Ask your lecturer. The proof is too difficult for us. Anyway, I'm just trying to make a point. Sometimes it's possible to know the final answer if you could continue forever. Yeah. It's possible to know this. In fact, remember the one I gave you earlier, this one here? 1 over n factorial, you got 2.7. I know if you could continue this forever, you would get 2.718828459045, etc. Does anybody recognize this number?
Yes.
Yeah, what is this?
Different numbers.
Oh.
Some people know this number. Yeah.
Sure.
Natural, for natural log. Yeah. Anyways, we're not worried about that today. For today, all we care about is going up to small numbers. Yeah. So it's not very difficult. It's not very difficult. You just need to use your calculator. You all have a calculator today? Correct?
Yeah.
Yes? Okay, so you can do some of them now, and then we'll just start the next lesson. Let's see. Let's just say the last 5. And it really should only take maybe 5 minutes with your calculator, okay? So give it a go.
Right?
No, do it now.